Good evening, Dr. Biswas. My name is Roberto Sainz, and I prepared this presentation with my partner, Brittany Fink. Our project, we are going to be analyzing a vehicle's cruise control as it travels through a dynamic environment. An overview of this presentation will go over the motivation for this project, our introduction on what cruise control is, our objective, as well as our appendix. In the world today, most modern vehicles are equipped with a system that simultaneously increases vehicle efficiency while also reducing driver fatigue. This system uses a combination of sensors and controllers to help the vehicle maintain a preset vehicle speed. The dynamic system has become commonly known as cruise control. The motivation behind choosing the analysis of a cruise control system is that it is a system that most people use on a daily basis and therefore is often taken for granted by the general public. It is one of the most desirable luxury options on any vehicle today and often comes standard on a wide variety of vehicle makes and models. The main function of the cruise control system is to maintain a constant preset vehicle speed, despite road conditions and environmental effects on the vehicle. Manufacturers in recent years have advanced the system to maintain a preset distance between your vehicle and the vehicle in front of you. This advanced cruise control system also incorporates the braking system of the vehicle for obstacle and collision avoidance. This advanced system has become known as adaptive cruise control and is being offered as standard equipment on many new vehicles coming off the lot. And more sophisticated vehicles offered, these systems have incorporated lane assist and self-driving functions. For an introduction of the cruise control system, a brief description of the history will be discussed, as well as an overview of conventional cruise control systems, including the differences in components between earlier mechanical cruise control and modern electric cruise control systems. A brief introduction to adaptive cruise control will also be covered, along with an overview of the system. The idea of cruise control first came into fruition in the 1700s. This system's original purpose was to control a steam engine's throttle input. It was mainly used by locomotive conductors to aid them in their long hauls across the Indian and European countries. It wasn't until the 1940s that cruise control was adapted to fit passenger vehicles. A mechanical engineer named Ralph Teeter patented the first design in the 1950s. Ralph Teeter was blind and therefore needed to be driven around by his lawyer. Teeter would become nauseous and frustrated with the non-consistent throttle input his lawyer drove with, and thus the idea of for passenger cruise control was born. The cruise control for passenger vehicles became increasingly popular in the United States in the mid-1960s and 70s. At this point, Dwight D. Eisenhower's Federal Aid Highway Act of 1956 had been completed, and the general public could use the U.S. interstate highway system with ease. With cruise control adapted on these vehicles, these long adventures became more comfortable for the average driver. Conventional cruise control systems' primary function is to adjust the throttle input of the vehicle to maintain a preset speed. The vehicle's instantaneous speed is constantly changing due to multiple factors while driving. These factors can include dampening force from the headwind against the vehicle, change in the grades of incline and declines in the road, as well as changes in the direction of the vehicle. Since there are multiple factors that can change the vehicle speed, the cruise control system falls under the class of a MIMO dynamic system. The term MIMO is an abbreviation for multiple inputs, multiple outputs. In older vehicles where most vehicle systems are mechanical, the cruise control system worked by a mechanical actuator attached to the throttle cable. Typically, this actuator was vacuum controlled and received input from the speed sensor. When a change in speed was apparent, the actuator would engage to adjust the throttle position to open or close the butterfly valve accordingly until the desired speed was achieved once again. Since the actuator physically moved the cable attached to the throttle pedal, the pedal inside the vehicle would physically move and would be problematic to some drivers if it was unsuspected. Newer vehicles have adapted to a drive-by-wire design. In this design, the throttle pedal is no longer connected mechanically to the throttle body. Instead, the throttle pedal is attached to a potentiometer or transformer, which alters an electrical signal. This signal is interpreted by the vehicle's engine control unit, or ECU, which lets the vehicle know where the desired throttle position should be. When cruise control is activated and engaged to compensate for a difference in speed, the computer can easily adjust throttle position on the throttle body using an electric motor. Since there is no mechanical connection to the pedal, when the electric cruise control accelerates the vehicle based on dynamic changes, the desired input can be achieved quickly and more accurately due to the computer inputs. Another benefit of this electrical design is that the pedal does not change position physically, which allows the driver to remove some guesswork when reverting to manual throttle input. This small feature aids in overall driving satisfaction as well as efficiency. In recent years, vehicle systems and controls have become highly sophisticated. New vehicles are now offering adaptive cruise control. Adaptive cruise control, or ACC, uses forward-facing cameras and sensors that can detect the distance between vehicles in front of the pilot vehicle. This system not only maintains vehicle speed, it also incorporates the braking system of the vehicle as well. If the forward-facing cameras or sensors detect that it is approaching a vehicle or obstacle too quickly, it will apply the brakes automatically to aid in the avoidance of a collision. Our objective of this assignment is to model the cruise control system and its components, such as throttle, speed sensor, and engine management, to better understand how the equipment talks to each other. Our other objective is to analyze how changes in environment and road conditions affect the vehicle and how the cruise control system nearly instantaneously adjusts for these changes. This is a block diagram of the cruise control system we will be analyzing. In our system, we have an input, a control module, actuator, a disturbance, and output feedback, as well as our sensor. In our system, our input is going to be the desired set speed for cruise control. Our control, it will send the signal to adjust the speed. Our actuator adjusts the RPM of the vehicle, usually at the throttle body. The disturbance will be wind, friction, or a driving incline, or even a change in direction that the vehicle undergoes. Our output is going to be the velocity of the speed after these changes have been made, as well as a feedback loop is incorporated to send the speed back through the sensor, which transmits the speed to the controller to ensure that the vehicle is behaving exactly how it should be. This is our Gantt chart. From our Gantt chart, our breakdown is displayed here. From here, we would like to expand more with the cruise control. Blue represents complete, red represents subjects that are in progress, and green is presented to show our planned objectives on where we try to be. This is our references, and is there any questions? Thank you for listening to our presentation. I hope that you all have a good evening. Thank you.